Problem number 32. It should be a very short problem. We're told f of 97 is equal to negative 115. We're told that f is 1 to 1. So what do we conclude here? F inverse of negative 115 is 97. So this is essentially, f is 1 to 1 on its domain, so we can talk about the inverse of f. So the f inverse of negative 115 is what input into f of x gives you a negative 115, and we're told that's 97. Okay, let's do a longer inverse problem. So we're taking a look at the function f of x is 37x plus 30 over x minus 86. We're told it's 1 to 1 on its domain. First question here, so let's say f is 1 to 1 on its domain. First question is, what is the domain? What is the domain? And so the domain is going to be, and we should be clear here, domain of f. The domain of f is going to be, so when can we have problems? Numerator is never going to present any issues for us. The denominator, we don't want it to be equal to 86. So x cannot equal 86. We're asked to write this using interval notation. So that's all numbers strictly less than 86. This is all numbers strictly larger than 86. Put a union symbol in between. I'm going to skip part B for the moment, find the range. I'm going to jump straight to finding the inverse of f inverse. The inverse, a formula for f inverse. So to find f inverse, what we're going to do is, you can think of this as equal to y. Let's interchange the roles of y and x here. So I'm going to write 37y plus 30 over y minus 86. This needs to equal x. And then I'm going to solve this equation here for y in terms of x. So I have x in terms of y. I want y in terms of x. Okay, let's multiply on both sides by y minus 86. So that gives us 37y plus 30 is equal to x times this. So that's xy minus 86x. Let's move all of the terms with an x in them to a y in them to one side. All the terms without a y in them to the other side. So we'll move the 86x to the left. 30 plus 86x is equal to xy minus 37y, which we can write as y times x minus 37. So now our final step is dividing both sides by x minus 37. Y is equal to 30 plus 86x divided by x minus 37. So this is our formula for f inverse. Okay. Now, why did I do this before I did part B? For part B is the range of f. And here is a fact. The range of f is equal to the domain of f inverse. So what's the domain of f inverse down here? Again, the only time that we can have an issue is if we're dividing by 0. Is if x is equal to 37. So we don't want x equal to 37. Writing this out in interval notation, negative infinity to 37, union 37 to infinity. So the domain of f this is also the range of f inverse, and the range of f is the domain of f inverse. Let me to finish off this problem, just point out, so we can get to any number other than x is equal to 37 from our formula. What happens if we try to set 37 is equal to 37x plus 30 divided by x minus 86. We multiply on both sides by x minus 86. We get 37x minus 37 times 86 is equal to 37x plus 30. The 37's x's cancel out, and we're just left with negative 37 times 86 is equal to 30. I don't want to do the arithmetic there, but those two numbers are certainly not equal to each other, so there's no solutions. So that is a way that you can see that that 37 is not in the domain of, not in the range of f. Okay, let's do one more problem on this theme of inverse functions. So let's look at problem number 34. So this one should be straightforward after the previous one. If f of x is equal to x minus 2 over 1 plus 5x, then how do we find the formula for f inverse of x? Well, as before, we're going to interchange the roles of x and y. So x is equal to y minus 2 over 1 plus 5y. And solve this for y in terms of x. Multiplying both sides by 1 plus 5x gives us, 1 plus 5y, and gives us x plus 5xy is equal to y minus 2. Let's add 2 to both sides, x plus 2, subtract 5xy from both sides. So we end up with y times 1 minus 5x. And dividing both sides by 1 minus 5x gives us y is equal to x plus 2 over 1 minus 5x. So this is our formula here, x plus 2 over 1 minus 5x. Okay, that's how you find the inverse function of f of x. Let me just point out here, one useful thing is that if we end up doing f composed with f inverse of x, we should get back the identity function. This should equal x. Let's actually do this calculation. So what this calculation is going to be, so f of x is x minus 2 over 1 plus 5 times x. But everywhere I see the x, I'm going to put in the formula we just found for the inverse function of f. So I'm going to replace this x with x plus 2 over 1 minus 5x. I'm going to replace this x down here with x plus 2 over 1 minus 5x. And so, as long as everything here is defined, this should give us the identity function back. Let's do some manipulation to see that. So in the numerator, we're going to put everything over a common factor of 1 minus 5x. So this would be x plus 2 minus 2 times 1 minus 5x. In the denominator, we're also going to put everything over a common denominator of 1 minus 5x. So that would be 1 minus 5x plus 5 times x plus 2, all that over 1 minus 5x. Okay, at this point then, those factors of 1 minus 5x cancel out. And we are just left with upstairs x plus 2 minus 2, and then distribute minus 2 times minus 5x is plus 10x. Downstairs we have 1 minus 5x plus 5x plus 10. And those 2's cancel, those 5x's cancel, and we are left with x plus 10x is 11x over 1 plus 10 is 11. Cancel out the 11's and you get x. So f composed with f inverse of x gives you the identity function back. Check for yourself if you want to that f inverse composed with f also gives you the identity function.